Welcome to an example in which we are testing two different percentages. Let's take a look at this question here. Are freshmen psychology majors more likely to change their major before they graduate compared to freshman business majors? So that's the question. 70% of the 600 freshman psychology majors from a recent study changed their major before they graduated, and 65% of the 680 freshman business majors changed their major before they graduated. What can be concluded at the alpha 0.05 significance level? Okay, so first question. For this study, we should use, now, what is it we're trying to do here? Well, notice we're comparing percentages, right? We have 70% of 600, 65% of 680. We're comparing two groups and the percentages of them. And so when they say, are freshman psych majors more likely to change their major? Well, it looks like it, right? 70% of them changed their major, and only 65% of the business majors changed their major. So yes, it looks like they're more likely. In fact, why do we even need to do some fancy statistical study? I mean, aren't we just done? 70% of the psych majors, of the 600 psych majors, changed their major. Only 65% of the business majors changed their major. So yeah, for sure. Psych majors are more likely. Right? Done. What are we going to do all this fancy stat stuff for? Right? It's an easy question. Well, they're not quite. It's not quite that simple. Why not? Why isn't it that simple? Because maybe this is a lucky sample. Do you see the problem? We're trying to answer the question in general, right? Are freshmen psych majors, like all freshmen? We all understand that when we ask that question, are freshmen psych majors, we don't just mean freshman psych majors at this specific college, right? We mean all in the world. Right? All psych majors in the world. More likely to change their major than all business majors in the world. We mean like overall, for all, is psychology a major for everybody that takes it that makes you more likely to change than business? Now you think, in this particular study, 600 psych majors, 680 business majors, the psych majors were more likely, but maybe that was just a lucky study. Maybe by random luck, for that particular college or whatever that study was, we happen to just by luck get more psych majors. But really, if you look at the whole world, it's not true. More psych majors don't change their major than business majors in the whole world. This was just a lucky sample. What's the chance that it was just luck? Well, that's the p-value down here, which we'll figure out. You see, that's always the problem in statistics. You're always saying, is there strong evidence that my sample really is telling the truth about the principle involved that's true for the whole world? You see how that's always what we're doing in statistics. And that's what we want to know in real life when they test a new cancer treatment or treatment for COVID or a vaccine for COVID or, some psychological fact like this one. They want to know what's true for the whole world. And they try to figure that out by doing a sample of a few people. And then they try to figure out what's the likelihood that that sample is really telling us the truth of the whole world. In other words, what's the chance this was just a lucky sample, or maybe it wasn't just lucky, it's really representative of the truth of the whole world. So that's always why we have to do this official statistics stuff, because we have to rule out the chance of random luck. Okay, so let's go to our exam 4 notes to figure out what to do here. Here are the exam 4 notes, and whoops, I just did a bit crazy thing there. And we're looking at number 1 up here, which is the two proportions. That's what we have, right? Two percentages, two proportions. In fact, I've got it nicely here for you, right there. I copied it so we can look at it more closely. So two proportions, number 1 on the exam 4 notes. Use the two proportion z-test or two proportion z-interval. We're doing z-test. This is a hypothesis test. That would be for a confidence interval. So two proportions, why? Because we have, what's new here, notice, is we have two groups, not just one. In the earlier material, when we did hypothesis tests, we would just have one group, but now we have two. We have the psych majors and the business majors. We have a percentage of the psych majors and a percentage of the business majors. So two groups, two proportions. We're going to use the 2 prop z test. And how do we set it up? The HO is P1 equals P2, and the H1 is going to be one of these. And you put in the successes, x1, x2, and total observations in for both samples. And, oh yeah, so let's answer this right. I'm getting ahead of myself. 2 prop z tests. So come up here. First thing they want us to say is that we're going to use here, your option here, will be a z test. 2 prop z test, right? Z test for the difference in 2 population proportions. That's what we're trying to figure out here. Okay, so what's our null hypothesis? Well, the null hypothesis is going to be, do they give me option of mu1 or p1? I want p1 because we're talking about percentages, right? Percentages, proportions, not mu, because that's for averages. We don't have any averages here. We have percentages. So P1 is, now HO is always equal, isn't it? Always equal. Come down here, you can see it in the notes. HO is all, for every hypothesis test we'll ever do, HO is always equal. And then H1 will be, again, you have P1 and P2. Notice we're talking about, group 1 and group 2, percentage 1 and percentage 2, or proportion 1, proportion 2, same thing, whatever. And the first group, of course, is the psych majors, and the second one is the business majors, right? And then same thing here, the P1 is the psych people, and the P2 is the business people, and are they equal? HO is equals, and H1 will be greater, less, or not equal. Let's see what it is. So H1 is equal, HO is equal, sorry. H1, what's H1 going to be? Well, it's whatever they're saying. What do you mean, what are they saying? Right here. More likely. They're saying, are the psych people more likely? That's greater. Is P1 greater than P2? More likely than the business people? Greater. That's what we're testing. Is P1 greater than P2? Is the percentage of psych people greater than the business people? P1 greater than P2. In fact, remember, we already said it kind of looks like it. 70% is bigger than 65. But we're wondering, maybe that was just a lucky sample. Is that really representative of the truth of the whole world and everybody that'll ever major in psych or business? Is that a true principle, or could luck have gotten in there? What's the chance of luck? That's the p-value. If it's very low, we'll rule it out and say, couldn't have been luck, this must be the true principle for the whole world. All right, let's get into it. So there's what we're going to test. Remember, HO, now in all hypothesis tests, I hope you remember, HO is always weak evidence, because we assume HO is true, like a court of law, right? When somebody accused comes in, you assume they're innocent. Let me not circle. We'll circle at the end when we're sure which answer. I don't want to confuse you with the early circling. So this is P1 equals P2 here. Anyway, so HO is always weak evidence, and H1 is always strong evidence, right? Because like a court of law, you assume HO. You assume when a person is accused that they're innocent. And if the evidence is weak, then you end up saying, well, the evidence was too weak. We're going to let them go. We're going to assume they are innocent. But if the evidence is strong, the way the court of law says is beyond a reasonable doubt, then we're going to reject the null and go with H1. Evidence is strong. Okay, so HO is always weak evidence. The HO is always the conclusion if evidence is weak, because that's what you assume in the beginning. H1 is always the conclusion if evidence is strong. Okay, so what test are we going to do? So we're going to go to our calculator now. We're going to do the 2 prop z test. Let's go there. So I'll write the notes over here on the side. So in fact, yeah, here. So go to your calculator and hit stat. Go over to test go down, so stat over to test, go down to number 6, which is 2 prop z test. Prop z test, and hit enter. And as soon as you do, you'll see a bunch of options. You'll see x1 in 1, x2 in 2, and then the p1. And I want you to say equals, greater, less. Okay, so let's go through this stuff. So how do we do this? What's x1 in 1? Well, down here I'm helping you out. Notice what I'm saying here. If given percentages for x1 and x2, like x1 is 32% of 490 and da-da-da, then you multiply and round and multiply and round. Is that what we're given? It's exactly what we're given, right? 70% of 600. 65% of 680. So in other words, what x1 is, it's going to be 70% times 600. Multiply in your calculator. You'll get 420. You'll get 420. And you can put that right into x1. And n1 is the 600. What are we saying? We're saying 70% of the 600 psych majors change their major. So that's 70% of 600. So of is multiply. Of is always multiply. So 70% of 600, so 0.70 times 600, so 420 psych majors. This is the psych that changed their major out of 600. Remember, n is always the total in group 1. N1 is the total number in group 1. N is always the total number in a sample. So 420 out of 600 changed their major for the psych people. And then x2, same kind of thing, 65% of 680, 0.65 times 680. What's that? Wait, got to put that in here. 0.65 times 680. You can type it right into your x2. It'll be 442 out of 680. That's the total of group 2. 680 people. So now the 442 business changed. 442 business majors changed their major out of 680 total business majors. So that's what the x1 is, how many, and the how many changed. N1 is the total group 1. X2 is how many business majors changed out of into 680 total. And then the last thing they want you to say, is this not equal, greater, less? We already have it right there. It's a greater than. So it's P1 greater than P2. You want to choose the greater than P2, because that's what we're testing right here, right? Is P1 greater than P2. So choose that option and calculate. So when I hit the calculate button, I got my test statistic. That is right here. That's Z equals, so the test statistic, Z equals, and I'm getting, they want 3 decimal places, negative 0.495. Rounded to 3 decimal places, and then the p-value, 4 decimal places, it says right here, 4 decimal places, 3 for the Z value. 4 is 0.6896. 0.6896. 0.6896. All right, so let me go back, double check my numbers, make sure everything's good. Oh wait, no, I'm sorry. I put in a wrong, I thought those numbers looked funny. I put in a wrong number. My mistake. Hold on, let me fix those. And greater. Okay. Sorry, I have the wrong numbers. I thought those numbers looked weird. So Z value is 1.904, rounded to 3 places. And the P value is 0.0284. 0.0284. Oh, sorry, 85. Having a rounding problem. 0.285. There we go. All right. So here comes the $1 million question. Is the p-value greater than or less than the alpha? That's always how we determine, right? If the evidence is strong or not, meaning is it beyond reasonable doubt? Knows is it beyond the chance it could have just been luck? Well, what was our p-value? Our PME, I don't know where to write it. Our kind of running out of room here. Let me put it right here. Get rid of this. So our p-value right here, p is 0.0285, and alpha, where's the alpha? Right there, 0.05, level of significance. So when they say the alpha is 0.05, they're saying, and that's how significant, they want less than a 5% chance of luck. So like in a court of law, they want, the way they say it is evidence beyond a reasonable doubt. And in this statistics problems, in statistics studies, they give us level of significance, meaning that's they want evidence lower than that chance of luck. They want evidence less than a 5% chance of luck. And if they get that, then they'll believe the evidence is strong and that what happened in the sample is really representative of the whole world. Well, did it? Yep, it did, huh? 0.02. That is certainly less. Oops, let me go with a different color there. Less. That p-value is less. 2% is less than 5%. We had only a 2% chance, or maybe you could round it to 3, 2.85% chance of luck. That means these results are so strong, right? We sampled a lot of people. That's why it's so strong. 600 freshmen psych majors and 680 freshman business majors, and more of the psych majors did indeed change their major than business majors, and that's a big sample. So it is very likely that didn't just happen by luck, right? You can't. That's 600 and 680 people. That can't be by luck. There's only a 2.85% chance that we got those results with the psych numbers coming out higher by luck, by random luck. That's a very low chance of that. No, that's probably representative of the truth of the whole world of all psych majors and business majors. In general, seems like psych majors change their major more. Yeah. So remember how we draw our final conclusion. Remember the statement we always use when we do a hypothesis test. Let me write this out for you. If the p is low, then the HO must go away. Remember that statement? That's what you want to say that to yourself every time you do a hypothesis test. If the p is low, the null must go away. Is the p low? Yeah, it's less. Now if it came out greater, then we would say if the p is not low, the null must not go away. Right? If it's greater, then it's not low. If you do your study and you get a p-value greater, then greater is not low. If your p is not low, then the null must not go away. But we got a null that's lower. I'm sorry, a p-value that's lower than alpha. So we have a very low chance of luck. We're under the bar, right? They said they want less than a 5% chance of luck. We got it. We got only a 2.85% chance. Our p is low. So when your p is low, the null must go away, which means we're going to what? Reject the null. Bye-bye, null. We're going to reject you. We're going to come up here. We're going to reject the null, and that means we're going to keep instead H1, aren't we? We keep H1. So come up here, and I'm going to circle H1. That's our conclusion. And I'm going to say no way to HO. Right? We reject the null. When the p is low, the null must go away. Reject the null, keep H1. So we're keeping H1. What does that mean? Evidence was strong, right? It was only 2.85% chance of luck. Very low chance of luck. Strong evidence, beyond a reasonable doubt. We do indeed believe that P1 is truly greater than P2 for all psych majors in the world. In general, psych majors have a greater chance of changing their major than business majors. This sample results were so strong, we believe it's a principle true of the whole world of psych and business majors, that more psych majors change their major than business majors. The evidence is strong. Let's read through the options here. The results are statistically insignificant. No, ours are significant. Let's cross out both those insignificant ones. The results are significant. The results are significant. Yes, okay. So what's the difference here? That the portion of 600 who changed their major is greater. Yeah, that's right. Greater. What is this sense? Change their major is greater than. Wait, they both seem the same thing. So there is sufficient evidence to conclude that the proportion of the 600 freshmen psych majors. Oh, they're tricking us. Okay, it's this one. Here it is. This is super tricky. This is almost mean. Notice it's important though. It is important. This one's correct. Why? What does it say? The results are significant. So there is sufficient evidence to conclude what? That the population, which means all in the world. That's what the population. So those words matter. I hope you're not skipping over those words. Population means all in the world. Remember, that's what we're trying to figure out. Do all psych majors in the world, the whole population, really change their major more than business majors? The population proportion of freshman psych majors who change their major is greater than the population of all business. Yeah, that's what. Well, what this say? No, this said the proportion of the 600. Well, of course we know that more of the 600 changed their major. That's not what we're trying to conclude. That's a no-brainer. We knew that from the beginning. Yeah, 70% of the 600, that's more than 65% of the 680. Yeah, more of this, in this sample, more psych majors changed. Yeah, for sure. But that was never what we were trying to figure out. We were trying to figure out if that sample gives us strong evidence that it's a true principle for the whole world, for the whole population. So here they're tricking us, right? So there is evidence to conclude that the 600? No, not the 600, not that. There's evidence to conclude that the population of all freshman psych majors who change their major is greater than the population of all business majors. There it is, the right answer.